Financial Modeling, Topic 3, Computing Portfolio Risk and Return by Lou Gaddis. References for this material include Financial Modeling, 4th edition by Simon Beninka, Chapters 8, which has portfolio models, portfolio mean and standard deviation, matrices in Chapter 32, and VBA objects in Chapter 39. We're going to be using the range object. The learning objectives for Topic 3, Compute Portfolio Expected Return. An introduction to matrix algebra. We're going to compute portfolio volatility using a correlation and covariance matrix. We'll then compute portfolio volatility using matrix multiplication. We'll compute volatility of a portfolio that combines a risky and risk-free asset. And we'll further our VBA programming skills by using VBA comments and the application.object. So let's get on to section 1, computing the portfolio expected return. So in this case here, I have some expected returns of and standard deviation weights of 3 assets. I have SPY, that's an ETF that tracks the S&P 500. That's roughly the 500 largest companies in the US. I have EFA, which is a global fund of equities, and what that includes are developed markets excluding North America. And then EEM is a ETF that tracks the emerging market index. That's developing economy stock markets. Now, in topics 1, we calculate the expected return using a bunch of models. Remember the Fama French, the CAPM, historical, global CAPM, fundamental analysis. Well, I've used that information along with my judgment, and I've come up with my best guesses for the next year for the expected returns of the S&P 500, EFA, and EMA. I've also used my best guesses to calculate the standard deviations of these assets or asset classes. So 16% volatility in the US, 18% in EFA, and 25% in EMA. Now what I'd like to do is form a portfolio of these 3 assets. That's 50% US, 40% EFA, and 10% EMA. So what we're going to do is we're going to first use a formula. The expected return of a portfolio, we'll call it RP, is the sum from I equal 1 to N WIRI. So let's talk about how to implement this formula. So what I'm going to do is I'm going to set up a table. And I'm going to have that table, and in this last example we had 3 assets, right? We had the US, EFA, and EMA. So I'm going to set I equal to 3 assets. So when we do the sum from I equal 1 to 3, WIRI, and I'll set up a table. I'll set I equal to 1, 2, and 3. And then I'll plug in my formula, WIRI. So when I is equal to 1, WIRI is equal to W1R1. I'll set I equal to 2, WIRI equals W2R2, and then I'll set I equal to 3. And since this says the sum, I'm going to sum up these 3 products, and I'll get the expected return of that 3 asset portfolio is the product, or is the sum of the products of the weights and returns. Now in Excel, what we're going to simply do, if the weights and the returns are simply in 2 rows or 2 columns, I'll just use the sum product function. And so let's go to Excel, the start file. And a couple things I want to do. I want to start using some name or range names. Let's take these 3 cells, B2, 3, 4, and notice where it says the cell reference here for the first one. I have 2, 3, and 4 highlighted. I'm going to call this RET for return and hit enter. Now anytime I want to refer to that cell, I can just type in RET, and I want to give this a name. I want to call that WTS for weights. WTS, enter. Now if you go, just for your information, if you go to Formulas, Name Manager, you can see I've set up returns, or RET, and weights. So now all I need to do under portfolio return is equal sum product, put in my return, comma, my weights, and enter. And the expected return of that 3 asset portfolio that combines these returns and these weights is 6.73%. So in this section, we've computed the expected return of a portfolio using simple formula, the sum WIRI. In the next topic, we'll do this. We'll have an introduction to matrix algebra, and we'll do that calculation using matrix algebra.